Hello everybody, welcome to our search channel. Now you are watching the video of 3D geometry. Actually, now we are going to find out the angle between two lines. You know, in 3D geometry, you have already studied that any line, say this is a 3D plane, and there is a line which is passing through a point A1 whose position vector is whose coordinate is x1, y1, z1, and this line is passing through a1 point, and its coordinate is x1, y1, z1, and this is also a parallel to a given vector, that is b1, and its its direction ratios is drs are its drs are a1, b1 and c1. Okay, now these are the direction ratios, and this is the point whose actual coordinate is x1, y1, z1, and at that moment what is the equation of this line? That is, you see, this is, we denote like that, r1 is equal to a1 plus lambda b1. Okay, for scalar value of lambda. Okay, so this is the vector form of this equation, r1 is equal to a1 plus lambda b1. And now take another line which is passing through point a2. Okay, and its coordinate is x2, y2, z2, and it is also parallel to a given vector, that is b2, and its direction ratios are a2, b2, c2. Okay, now you see here, then what will be the equation of this line? That will be r2 is equal to a2 plus lambda b2. Okay, this is the vector equations. This and this are two vector equations. Now you see here, if I increase this line, and they will meet with each other and make an angle here. And now if I increase the parallel vectors of the line, you see here like that, then it will also intersect in a point. And also see here, actually a1 parallel is b1 and a2 parallel is b2, and a1 and a2 lines and a1 and a2 lines, actually the line passing through a1 and line passing through a2, they are intersecting at a point, this point, and this angle is theta. And so b1 and b2 respectively parallel to a1 and respectively parallel to a2. Just shortly I'm telling this is a2 because actually not only this is a2, actually this line is passing through a2, and this angle also theta. Actually what happens, so this theta and this theta are the same. And now if I want to calculate the this value of theta, actually what should I take? If I take these two vectors b1 and b2, and we know how to find out the angle between two vectors, that is, everybody know that is cos theta is equal to vector b1 dot vector b2 by magnitude of b1 and magnitude of b2. Okay, this is the angle theta. Actually we need to find out first from the equation the parallel vectors and b1 and b2, and we shall put the value here. Okay, now what will be the Cartesian form of this equation? So here you see here, the direction ratios here a1, b1, c1 of vector b1. Vector b1's direction ratios are a1, b1, c1, and b2's direction ratio are a2, b2, c2. And so instead of b1 I shall write what? a1i plus b1j plus c1k. Okay, the cos theta, our cos theta will be, see here, our cos theta will be equal to, actually I am putting the value of b1 here, its value is its direction ratios are a1, b1, c1, and B2's direction ratios are A to I plus B to J plus C to K, and we have to take magnitude of B1. Its magnitude I am directly writing. This vector's magnitude will be under root of A1 square plus B1 square plus C1 square, and this vector's magnitude will be what? A2 square plus B2 square plus C2 square. And you know, in vector scalar product, in analytical form, I have shown you that if I multiply this one, then I into I square, and I square value is 1, and I into j is 0, j into k 0, I j 0, ki 0. So all will be 0, only will be left a1 a2 plus b1 b2 plus c1 c2 under root by a1 square plus b1 square plus c1 square under root into a2 square plus b2 square plus c2 square. This is the Cartesian form. Okay, the value of cos theta here, cos theta is equal to this in this type. Actually you have to need not to remember the whole formula. Actually, if you know the actual funda, what is the how the equation is coming. Actually here, see here, the angle between two lines is nothing but when the lines are passing through a given vector, and that vector you have to find out, and after that you will put the value of b1's direction ratios, b2's direction ratios, and after that you can easily calculate the theta angle between two lines. I hope you understood this video. If you like this video, please subscribe my channel.